In this video, we're going to be solving questions on sets. Let's start with this question number 1. If set P is equals to x such that x is greater than or equals to 2 but less than 10, where x is prime, and then set Q is equals to x such that x is greater than or equals to 2 but less than or equals to 13, where this x is odd, we ask to find A, P union Q, B, P intersection Q, C, we ask to evaluate the number of elements in the set P union Q plus the number of elements in the set P intersection Q. So let's start by writing solution. Now before I go on to solve this question, I want to let you know that I have previously made a video where I explained sets and its properties. So if you want to watch it, you check the link of the video in the description. I will put it there. Now back to the question. Let's first of all list the elements that are within this range. That's x is greater than or equals to 2 but less than 10. So I'm going to start from 2 and end at 9. So we have that x is equals to 2, 3, 4, 5, 6, 7, 8, and 9. So x is less than 10. We're not going to include 10. X is greater than or equals to 2. We're going to include 2. Alright? So this set P is made up of x, and then here's the restriction or the condition that x must be a prime number. Now we're going to list the set of P. Now amongst these numbers, which of them are prime numbers? Remember that prime number is a number which no other number can divide except itself and 1, but 1 is not a prime number. The reason why 1 is not a prime number is because a prime number must have two factors, right? Itself and 1, but 1 has only one factor, which is itself, that is 1. So that's why 1 is not a prime number. So here 2 is a prime number because no other number can divide 2 except 2 and 1, so we pick 2. 3 is a prime number, we pick 3. 4, 2 can divide 4, so 4 is not a prime number. 5 is a prime number, no other number can divide it except 5 and 1. Now 6 is not a prime number. 7 is a prime number. 8 and 9 are not prime numbers, so we close the set. So this is set P, 2, 3, 5, and 7. Now how about set Q? Set Q is equals to x such that x is greater than or equals to 2 but less than or equals to 13. So let's list the numbers that are within this range. X is greater than or equals to 2. We're going to start from 2 and stop at 13 because x is less than or equals to 13. So you have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now the restriction is that x must be odd number. So set Q is made up of the following elements. Now the condition here is that x is odd, that's odd number, and an odd number is a number that cannot be divided by 2 without a remainder. So 3 divided by 2 is 1.5. Because there is a remainder, the answer is not a whole number, then we say that 3 is odd number. So we write 3 here. Now other odd numbers here are 5, 7, 9, 11, and 13. So we have 3, 5, 7, 9, 11, and 13. Now the first question A said that we should find P union Q. So we have that P union Q is equals to, so how do we determine the number of elements in this set P union Q? Now we're going to join these two sets P and Q without repeating any element. Alright, if you look at this set P, you see that we have 3 here. Set Q, we have 3 here. We're not going to write 3 twice. We're just going to pick only one of them, right? So let's go ahead and join the two sets. We have 2 here, then we have 3 here. We also have 3 here, but we're going to write only one. So we have 5 here. We also have 5 here, but we're going to write only one. Now we have 7, then we have 9, we have 11, and we have 13. Now the second question is find P intersection Q. So P intersection Q is given by, now intersection is what these two sets P and Q have in common. If you look at this set P, we have 3 here, and then this is 3 here, and this set Q we have 3 here, so they have 3 in common. We pick 3. We have 5 here, we have 5 here, so they have 5 in common. We have 7 here, we have 7 here, so they have 7 in common. So this is the elements that are made up of the set P intersection Q. Now this C says we should evaluate the number of elements in the set P union Q plus number of elements in the set P intersection Q. So this is going to be given by NP union Q is equals to, we're going to count the number of elements in this set P union Q. So this is 1, 2, 3, 4, 5, 6, 7. So we have 7 here. Now the number of elements in P intersection Q, so this is just 1, 2, 3. So we have 3 here. Now N P union Q plus N P intersection Q is going to be equals to 7 plus 3, which is equals to 10. Alright, so 10 is the answer to this question C. Let's go and solve the second question. Question number 2. Given that P and Q are sets of real numbers such that P is equals to X, where X is greater than or equals to 0 but less than or equals to 3, and Q is equals to X such that X is greater than minus 3 but less than 2, find P union Q. So we write solution. Now let's list the elements that are in set P. So the condition we're given here is that X must be greater than or equals to 0 but less than or equals to 3. So we're going to start from 0. We have 1, 2, and 3. And then for set Q, we have that X is greater than minus 3 but less than 2. So we're going to start with, now recall that in number line we have minus 3, minus 2, minus 1, 0, then 1, 2, 3, and so on. So now given that X is greater than minus 3, right, so we're going to start from minus 2 because this is the ascending order of this number line. So we're going to start from minus 2. So we have minus 2, we have minus 1, we have 0, and then 1 because X is less than 2. Alright, so these are the elements in set Q. Now let's find P union Q. P union Q. So this is equals to, we're going to combine or join the two sets. So we're going to start from 0. No, we're going to start from negative 2 because this one is the smallest. We have negative 2, we have minus 1, we have 0, we have 1, now we have 2 and 3, then we have 2 and 3. Now these are the elements in set P union Q which we have to find. Now in addition, let's find P intersection Q. Do they have anything in common? Let's find out. So we have 0 here and then we have 0 here. so they have 0 in common. Is there any other thing? We have 1 here and we have 1 here. They have 1 in common. We have 2 here, we don't have 2 here. We have 3 here, we don't have 3 here. We have -2 and -1 here, but they are absent here. So these are the only elements in the set P intersection Q. Alright, so let's move to the next question. Question number 3. If the universal set U is made up of X such that X is a natural number and X is greater than or equals to 1 but less than or equals to 9, then the subset P is equals to X such that X is greater than or equals to 1 but less than 4 and Q is equals to 2, 4, 6 and 8. We have to find P union Q complement and P intersection Q. So we start by writing solution. Now let's list the elements of this universal set. So U is equals to, we are told that X is a natural number and X is greater than or equals to 1 but less than or equals to 9. So all the numbers here are natural numbers, so we're going to list them out. And then we're going to start from 1 because 1 is included here. X is greater than or equals to 1 but less than or equals to 9. So we're going to start from 1 and stop at 9. So have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is the universal set. Let's list the elements in this subset P. So here we are told that X is greater than or equals to 1 but less than 4. So we're going to start from 1 and stop at 3. So we have 1, 2 and 3. Then for Q, we have that Q is equals to 2, 4, 6 and 8. Now the question says find P union Q complement. First of all, let's write out the elements in set P union Q. So we have that P union Q is equals to, we're going to combine these two sets without repeating any element. So we're going to have 1 here, we have 2 here, we have 3 here, then we have 4, this one, then 6 and 8. So this is P union Q, but what we asked to find is P union Q complement. So what it means is that we are going to subtract the elements of this P union Q from this universal set and list the remaining elements. So we have that P union Q complement is equals to, now we have 1 here, we have 1 here, we eliminate it. We have 2 here, we have 2 here, we eliminate it. 3, 4, 6, let's eliminate 3, 4 and 6, and then 8, we eliminate 8. So we're going to be left with only 5, 7, 9 and 10. So we have 5, 7, 9 and 10. Now these are the elements of this set P union Q complement. Now the next one is P intersection Q. So P intersection Q is made up of the following elements. Do they have anything in common? Let's find out. We have 1 here, we don't have 1 here. Okay, we have 2 here, we have 2 here. So we write it down. Is there another one? We have 3 here. Do we have 3 here? No 3 here. So 2 is the only element of the set P intersection Q. Thank you for watching. Please don't forget to subscribe to this channel, like this video, share with your friends and drop a comment. Enjoy the rest of your day.